Assalamu alaikum everyone. Welcome back to mathematics. We are doing A-levels paper pure maths 1, paper code 9709, variant 13, May June 2025, and we are doing question number 10. A curve has equation y equals to 9 over 2x minus 5 plus 2x minus 5. Find the coordinates of the two stationary points. So whenever we have stationary points, what do? We differentiate the equation and put this equals to 0 to get the coordinates of stationary point. Because if your curve is like this or like this, what is dy by dx? It is actually the gradient of the tangent. And we know at stationary points, that are your turning points, the tangent would be like this, parallel to the x-axis, and any line, horizontal line, for that the gradient is 0. So that is why we always put dy by dx equals to 0 whenever we have to find the coordinates of the stationary point. Okay, so this is what we are going to do. Now let's find out the derivative for this. So we have the equation to be y equals 9 over 2x, y equals 9 over 2x minus 5. Okay, so we cannot differentiate this in the denominator, so I am writing this in the numerator. 2x minus 5 to the power minus 1 plus 2x minus 5. Now finding dy by dx. So in xn minus 1, so it will give you minus 1 times, so I am multiplying it initially, 2x minus 5, and minus will give you minus 2 times 2 plus 2. Okay, and the derivative of 5 will be 0. Now it will give you minus 9 over 2x minus 5 square. Okay, 9 2 times is 18, so it should be better if we'll write it directly. Minus 18 plus 2. Okay, we have to put this equals to 0. Okay, this is equals to 0, so this will give you 2 equals 18 over 2x minus 5 square. Now cross multiplying, 2 times 2x minus 5 square equals 18. This gives you 2x minus 5 whole square equals 9. I'm cancelling 2 with this 18. So now expanding this, 4x square plus 25 minus 20x minus 9 equals 0. So this gives you 4x square minus 20x plus 16. We can make it simple. So x square minus 4 5 times plus 4 times 16 equals 0. Now we need to find the two x values because they say two stationary points coordinates. So yeah. Now breaking the middle term, which two numbers upon multiplication give you 4, and when added or subtracted give you 5. So 4 and 1. So x square minus 4x minus x plus 4 equals 0. That gives you x, taking x common gives you x minus 4, minus 1 common gives us x minus 4. Okay, I'm factorizing properly by breaking middle term. So this gives you either x equals to 1 or x equals to 4. Now we can find the y coordinates for the values as well, and these are y equals 9 over 2 x minus 5 plus 2x minus 5. So that gives you 9 over 2 minus 5 is minus 3 plus 2 minus 5. So minus 3 plus 2 minus 5 gives you minus 8 plus 2 gives you minus 6. So one coordinate must be 1 comma minus 6, like 1 point, and the other point would be when you substitute x equals to 4. So y equals 9 over 2x minus 5 plus 2x minus 5. That gives you 3 plus 8 minus 5. 3 plus 8 minus 5. 11 minus 5 is 6. So that gives you 4 comma 6 as the other stationary point. Okay. Now we have to find, now in part B they say, this is part A, and now we need to do part B. They say find d square y over dx square and hence determine the nature of each stationary point. So first thing is, this is your first derivative. This equation is your first derivative. Now we have to differentiate it again to find this nature of the stationary point. And we know, how do we get it? If this value is positive greater than 0, then it is minima. And if it is negative less than 0, then it is maxima. So let's do that. First, I'm rewriting the value of derivative, and that is, okay, I'm writing it again in a way that we can differentiate it. Minus 18 times 2x minus 5 minus 2 plus 2. Okay, someone was asking, like, why do we shift it back downwards and then we take it again to the numerator? So we shift this negative power down in the denominator, like we take the reciprocal, because when we take put the values 2 power minus 2, we can't solve it this way. We have to do it 1 to the power 2 square, then we can do it 1 over 4. So whenever we put the values in our expression, your power must be positive. So that is why we always keep it in the standard form, original form, simplified form. That is, power must be positive. Okay. Now differentiating this, d square y over dx square gives you an x n minus 1 times 2. 18 2 times is 36. So 36. Okay, also we have to multiply it again, so that becomes 72. 72 over 2x minus 5 to the power 3. Okay, this is your second derivative. Now we will use this second derivative and substitute it in our x values. to know which value is your where it is maxima and where it is minima. So let's take that equation on the next page. Okay, so substituting in the values for x equals to 1, your second derivative would be 72 over 2 minus 5 to the power 3. That becomes 3 cube. No, minus 3 cube. Okay, and this minus 3 will make it a negative number, minus 72 over 27. So that is less than 0, negative. That means you have a relative maxima here. Okay, now substituting the value x equals to 4. So for x equals 4, this becomes 2 times 4. So this becomes 72 over 8 minus 5 is 3, 3 cube. 72 over 27, that is greater than 0, that is positive. That means we have a relative minima here. Okay, so your curve is going to be like at x equals to 1 and x equals to 4. So like this. If this is 4, this is x equals to 1. So it must be somehow, your curve must look like this. Okay, this is not compulsory, I'm just giving you an idea. Now what they say, obviously the equation could be a different, it's not a cubic equation, it could be a different equation as well. Okay, so part C1 we are doing, and state the coordinates of maximum point of C1. So there are two things happening here, translation followed by reflection. So let's see what are the coordinates of your maximum point. Taking this part of the question to the next page. So we have the maximum coordinates are at maxima. We have maxima is at 1 comma minus 6. So when a translation is happening, that means simply just coordinates, this translation vector will be added in the coordinates. So 1 minus 3. Okay, 1. Okay, write it more simpler. 1 plus minus 3, comma, minus 6 plus 7. So this becomes 1 minus 3, comma, minus 6 plus 7 is 1. That gives you minus 2. comma 1. Then they say followed by reflection. So the reflection would be, reflection must be in reflection in x-axis. So if you see this, if this curve is reflected in x-axis, that means it becomes like this. So what does it mean? That every positive y coordinate has become negative y. Okay, so what we will be doing, reflection in x-axis means only sign of y is changed. So -2 comma -1 will be your final coordinates after reflection. Now there is a little trouble or problem in this question, and that is, in marking scheme they are giving us a different answer, and their answer is 1 comma -13, I guess. Yeah, 1 comma -13. And that is only possible when first reflection happens and then translation. Okay, here in the transformation, the order matters a lot. But the problem is, you must understand the sentence. So the followed by term actually tells us that this has happened first. Whatever is written first is happening first, and whatever is written after followed by should be your second thing to happen. Okay, so if we will do reflection first and then translation, then we can get this value. So I am hoping, like I am finding this as an error in marking scheme, but it's not official yet. I guess whenever I get to know that officially it is released that it's an error, I will let you know in the comment section. But I'll let you know how does, like, if you get a question like whenever reflection happens first, so what will happen actually? That means this reflection has happened first if, so what has happened means the thing becomes that your maxima that was first maxima becomes minima, and your minima becomes maxima. And now you will find the translation for new maxima. And when you will do that, you will get, so your new maxima will be this 4 comma 6. Okay, this has become 4 comma 6. Instead, it should also become 4 comma -6 because it has reflected first. Now, yeah, after reflection, this is reflection first and then translation. So when you do translation in this, it will become 4 -3 and -6 plus 7. It should also not give you this. 4 minus 3 will be 1. -6 plus 7 should be 1. It is also not correct. How they are giving, like according to marking scheme, what they are doing, they are just taking this to be maxima as 4 comma 6. And then when they add in this positive 6, 7, this will give you 13. So there is a lot of error in this part. So I hope we'll get the corrected marking scheme soon. Now let's do part C2. C2 says find the equation of the C1 in the form y equals to a over bx plus c plus dx plus e. Now what we actually need to do, apply these transformations on this. So let's try this. Doing question C part 2. Okay, shifting this forward. Also the equation. Um, So they are saying find the equation of C1. C1, how did we get C1? When we applied the transformations. Okay, first the translation and then the reflection. So let's look into this. So what we have done is, they say the translation is something is like in the function or in the equation. We have, if it is written -3, that means 3 units to the left. Okay. And how do we represent it in terms of function? We represent it by f of x plus 3. F of x plus 3 represents 3 units to the left. And when we say 7 in y-axis is added, so we write it as f of x plus 7. Okay. And lastly, when we will say reflection in x-axis, so that means f of x or your equation must be multiplied by -1 or minus sign. Okay, so this is how you understand this transformation. So let's do this. First of all, translation, that is like x is added in 3 is added in the x. So take that f y. Okay, applying simultaneously. 7 must be added in y and 3 must be added in x. This will become 9 over 2. In place of x, what we will be writing? We'll be writing x plus 3 minus 5 plus 2x minus 5. In place of x, we will be writing x plus 3. Okay, also I just wanted to write plus 7 also in this form. So now you will simplify this first and then apply the reflection. So this is what we are applying, translation. Simplifying this, we'll get 9 over 2x plus 6 minus 5 plus 2x plus 6 minus 5. So that gives you 9 over 2x plus 1 plus 2x plus 1. And now we are taking 7 on the other side. Or you can add 7 here plus 7 like this because it is added in y. Okay. But this is also fine. You'll get 9 over 2x plus 1 plus 2x plus 1 minus 7 is, sorry, no, we must not be adding it here. Obviously, if it is added in y, it must be added it in the equation on this side. Okay, sorry, it was not right to say this. Plus 7 must be here because like this is your whole equation and y is added means it should be added whole here. It should not be added on the left hand side because when you say function of x, something is added in the function, that means it should be f of x plus 7. Okay, if something is added in the y. So this is how it is. So let's correct this. Now this becomes plus 7 plus 7 plus 7. So that gives you 2x plus 8. Now apply the reflection. It will give you y equals okay, negative of f of x. So the whole equation of right hand side must be multiplied with negative. So 9 over 2x plus 1 plus 2x plus 8. Now when subtracted by negative, so it will become minus of 9 over 2x plus 1 minus 2x minus of 8. So this is how we can get the equation after applying the transformations in this required sequence. So this is your whole working for question number 10. Question number 10 was a bit tricky from part C. Okay, we have to do translation followed by reflection. So you must, your English must be correct. Okay, so if you know what does this mean, so you will be able to identify the order of transformations and then you will be able to solve it properly. So we have applied the translation first and then reflection. So we get these coordinates. And then for part C2 also, we have to understand the changes in the equation according to the given order of transformation. That's all about question number 10. Thank you.